So good afternoon. Can you hear me? And
good afternoon.
Hello, Professor.
Yes, we can hear clear.
Yes, everything seems all right. Thank you. Okay, so this is lecture number 20. Nothing to say about the material. I've just added the last lecture on the videos. For the next lecture, the next one, Friday, will be the last lecture of our program. And for today, we have 5 presentations. I think that it's necessary to start immediately. Today, I will not say anything about the last subject, the coatings. We will do something more on Friday. But today, because we have 5 presentations, I think we need to start quickly and go on until the end of the lecture. For the presentations today.
Excuse me, Professor.
Yes, please.
I have a small question. It's about the last lesson, so the lesson of the 7th of May. I don't know if you have already uploaded on YouTube or not.
So let me check. Okay, videos. Yes, and not in the YouTube channel, but directly on the Dropbox folder. Let me show to you. Can you see? This is the Dropbox folder, and you have the last lecture dedicated to coatings.
Okay, thank you.
Okay. So now I must move to the here. As I said before, today we have 5 presentations. Can you confirm that all the students, all the 5 groups are here?
Group number 13 is here.
Group 10, yes.
Group number 12 is here.
Group 11 here.
Group 9 is with us?
Yes, Professor, we are here. Yes.
Okay. So everything seems all right. So as I said, it's the time for you to speak, and I don't know who wants to be the first. We can follow the numbers I have here. So if you agree, we can start with group number 9, which title is Rattan as substitute for wood, and we have here Yazan and Zafnat. Excuse me if I didn't pronounce your names correctly.
It's correct. It's correct.
Yes, Professor. We go first.
That's correct.
Okay, so you can share your presentations.
Yeah, I'm sharing my slides. Can you see the presentation?
Yes, yes.
Yeah, okay. So, good afternoon, everyone. Good afternoon, Professor. Good afternoon, my colleagues. We are from Group 9. Today we are going to give you a small presentation about rattan. So, we are going to talk about rattan as a non-timber forest product. Before we start, I'm going to give a quick overview. So first, we are going to give an introduction. What is rattan? How to harvest them, and after that, we are going to give a small explanation about the mechanical properties of rattan. And after that, we are going to talk about the application of rattan. And then after that, we are going to explain a small case about rattan as a declining non-timber forest product. And finally, we are going to close with conclusion. So again, before we start, this is us, Group 9, Yazan and me, Zafnat. So yeah, what is exactly rattan? Rattan originated from Malay words as rotan. It's a collective name for approximately 600 species of palms from Calame family. Rattan has probably utilized for long as human has lived in the tropical forest here in Asia and Africa, and also the trading for rattans is ancient as well. So again, rattans are climbers, so it's like a vine, like a grape, also that use thorny stems and leaves to hold on the supporting structures of other plant species. They are cultivated either within forests or a special rattan garden, where is rattan planted after first years of agricultural production. So we have here, like I said earlier, it's 600 species. Most of them is from the Calamus family, and it's as you can see here from Africa, South Asia, also China, and also a little bit Eastern Australia. Here is Sumatra, Borneo, Java is Indonesia, Southeast Asian, also Laos, Thailand, yeah, Malaysia. Okay. Rattan is used to making goods like furniture for national and international markets. It became an important economic crop of my country, Indonesia, at the end of 60, with the growing motorization of river transportation, because most of the rattan garden or the forest is in Kalimantan, Borneo, and an increase in the number of trades and exporters. By the 70s, Indonesia had become the supplier of about 90% of the world's cane. First, going to Singapore for processing and conversion. And then in the late 70s, Hong Kong imported some rattan products worth over 68 million US dollar in export value. So we are going to talk about how to harvest rattan, please, Yazan.
Yes, thank you. Good afternoon, everybody. I'll continue what Zafnat just started. Here I speak about how to harvest rattan and how to take it from forests. Usually rattan wood is ready to harvest after 5 to 7 years after planting. The general harvest cycle is from 3 to 4 years. Each cluster of rattan stems yield around 20 to 25 kilograms. Usually, the harvesters or the farmers can carry up to, let's say, 40 or 50 kilos. So with a simple tooling, they can carry about 40 kilos or 45 kilos from the forest for each, let's say, for each batch. They do cut for harvesting. They do cut the stems above 1 meter from the ground and start pulling the rest of the climbers for their supports, and the leaves that support let's say supported with other plants around. So they start pulling them and then cutting the leaves, cutting the let's say removing the skin. I want my colleagues, if not, to hit the next slide so we can see a video if it's possible. Yes, let's go. Yeah, North Kalimantan and Indonesia. That's the country where Zafnat came from. Yeah, farmers go to the farm for the like the forest. Also, rattan can be planted inside forests, and let's say Sweden areas also lands. Also, what we can see is, you just pass? Yeah. This is the way that they remove the skin, they remove the leaves, they're pulling the rattan wood, and you can see it's like a round wood, pulling it from other. It's like a rope actually, where they are pulling and removing for the for the skin, and some stems and some knots also are removed. Okay, and then you can see whenever they will cut it right now. Yeah. You can pass it. You can pass it, Zafna. Yeah. You can pass it. You're still the cutting. Yeah. Here. Yes. After collecting it, here comes the part where they cut it into pieces. It depends where they're here, and they qualify it as like good quality or bad quality. They like, let's say, if some of them has some defects or cannot be used, they will throw it, and then the others will just control their let's say their length, and then that's it. They will head it to the market for maybe that's simple treatment like post-processing, and then to the market for sale. Yes.
Okay. Should we go back to the slides?
Yeah. Let's go back. Yes. Yeah. So properties of rattan. Some mechanical properties that it is generally lightweight, durable, flexible, and it has a really good strength. It differs from bamboo. Also, for a study that we had in a paper, that they were just like differentiating between rattan, bamboo, and steel, and we were more interested in knowing the range of the yield strength for megapascal. It's from 46 till 75. Ultimate like the mean ultimate the mean ultimate strength megapascal is 85.35. The elongation range percentage is out of 8 till 14. Other than that, steel and bamboo are much higher. So let's say rattan can't at this point, rattan can't be, let's say, infrastructure for reinforcement. Let's say, for example, for concrete beams to be for construction or such and such. So it's just we took here these values. Continue. Yes, and here for the applications, I'll start talking about the manufacturing methods. With like a small diameter rattan, there are some steps that can be that should be done actually. Like after we saw it, they already cut the rattan, removed the sheath, and sort the harvest. The middlemen usually they clean it, sanding and washing, after which the rattan is transported by the river. Yeah, it was like let's say the old transportation by the river. And you can see here in the picture, it's straightening. Yeah, after the material selection, detecting the good quality and the bad quality ones, and then straightening it, and then cross-cutting it, and which means that split into core and peel, and then if it needs some, let's say, bending, molding, and some others like drilling on or such, or something like that. Yeah, rattan wood is solid. This is the main, like a big difference from rattan to bamboo. So they put the sub assembly, and then it's final assembly, and then this is the final product. But usually back then they were transferred those like those goods from the rattan wood by sea to Java. From Kalimantan, where it's split, as I told you. Finally, the manufacturer uses rattan for weaving and other products. Yes, what is rattan used for? Mainly for some parts of furniture. It's nice, it's classic. We used to have it in our house back home. Some chairs, some let's say rubbish bin, or tables, and some baskets. It's really and it's actually mainly it's a bending wood, because it's let's say flexibility, and it's long steams. Also, once split, rattan has a great variety of uses. Okay, we're seeing this sleeping mats, baskets, all sizes of baskets, furniture, and also but they are being replaced by synthetic rattans. If we are using this, as we know that in this course we took modified wood is used for furniture for outdoor. So here it's the same thing. Let's say natural rattans can be for the outside or outside furniture, let's say outdoor furniture. So yeah, it's replaced by the synthetic rattans.
Okay, so all of that facts from research, from papers, might seem good. Seems good, like a high number of economical value, things like that. But actually, nowadays we have a serious problem. So rattan is start to declining. The value of the rattan start to declining. And this study covers why. So this study is done, conducted by CIFOR, is a Center for International Forestry Research in Indonesia. So yeah, this is the total area for two location. In Modang and Rantau Layung. It's in East Kalimantan. So as we can see here, the commercial rattan densities is 500.8, and 227.1. So these numbers seems good, but actually day by day nowadays they start to value less and less, as we can see here. So what happened during that time? So during that time we can get some money, produce or make monies until 68 million US dollar. It was because there is no ban policy that time, and Indonesia export the raw material or maybe semi-processed to another country. So as we can see here, the chart, this is the show the highest results. But then after 2 years, there is a export ban policy, and it's starting to completely different level. It's like half of it, like 2 years ago, and then after a few years, there is another change of the policies. So now until today there is a partial export ban. So only semi-processed and full product like goods can be exported. And also here we can see the raw rattan price, US dollar per kilogram is getting lower and lower. This is started from the 84, and it's getting lower and lower. Why? What happened? Because a lot of factors. So the CIFOR, the researcher, conducted some interviews to all the stakeholders from rattan farmers, from the collectors, to the traders, until the local government in Java, or until the furniture producers, except government. Government like the main government, it's not interviewed. So they gave results. The main factors that influence export volumes are relative value of the rupiah. So the low currency exchange rates that time. Also Indonesian credit interest rates. So it's also low because the banking system is not really good that time. International demand for rattan products is also getting lower and lower. Also, for example, like competition from other countries like China or another country in Southeast Asia that also produce rattan, and another furniture producing company or countries. Another example also, because there is lack of promotion. That makes the market doesn't really know that Indonesia can produce or sell high quality rattan and rattan product. Yeah, so that's the reason why it's declining. So now we are going to close with conclusion.
Yeah. Actually, rattan is an important non-wood forest product with an inherent capacity for growth among Asia, like in Indonesia, of course, and also in Africa. It has been used for domestic needs as well as internationally tradable merchandise. As merchandise, it has found its way to the international market and contributes to foreign exchange earnings.
Yeah, also based on this case, it would be helpful if different interest groups could be brought together by sharing the data that they collect, and also the relationships between policies, prices, and the trade volumes, so that the stakeholders like the farmer or the middleman or maybe the furniture company can develop together, and they can maximize the benefits for all of these stakeholders along Indonesia's market chain. Also, that's some based on this research, it's also available for these stakeholders to use. It's not like a less research paper, something like that, but it's really available so that the paper can support the future of rattan development. So it is really necessary. It is imperative that scientific groups encourage policymakers like a government to adopt the strategic action development plans and explore further of these important species. So yeah, that covers all of our presentations. Thank you.
Thank you very much.
Thank you to you. Thank you to you. A very, very rich presentation with many different subjects related with the rattan, not only the material itself, but also the marketing strategies, the policy, the competitors, and so it's a really an interesting presentation, as I said. Are there questions from the students? Okay, and it seems that at the moment there are no questions. I've a curiosity. I didn't get very well if rattan is a virgin material or is it cultivated? I don't know if I was my question was clear. So
yeah, so it's not actually wood because it's rich in fiber, so it's cultivated, so people can plant and live for a year, and then they can gradually harvest the rattan.
Okay. Okay, so because from the video, it was not so evident that it's planted, because it seems really a forest, not a cultivation. And when you mention the synthetic rattan, I think that it is plastic. It's not yeah.
Plastic,
no. Yeah, because we see also here in Italy some shops with this synthetic rattan, but it's plastic. It's not.
Yeah.
And this data about the decreasing of the rattan market in Indonesia is a general or is specific for only for Indonesia. So it's a general interest that is decreasing about this material, or is specific because of what you said about the ban, the policies, the marketing strategies, and so on?
Yeah, it's specific for Indonesia because the research, the paper also written by scientists, like a group of scientists, international, but they work for this CIFOR, for forestry research in Indonesia.
Mm-hmm. Okay. So thank you. So if there are no other questions from the other students, I think that we can close here this first presentation. Thank you again, Sasnata and Alno and Yazan. Yazan is better. Yazan. Where are you from, Yazan?
I'm from Jordan.
Jordan. Okay.
Yeah, far away from Indonesia. So.
Okay. Thank you again, and now it's time for group number 10. It's an Italian group in this case, I think, Alessandro and Francesco.
Yes.
Good afternoon.
And the title of your presentation is Wood as an Alternative to Oil.
Yeah.
So please start and share your presentation with us.
Can you see the presentation?
Yes, very well.
Okay. Good afternoon, everyone. Today, me and my colleague Francesco will present you our topic, which is wood as an alternative to oil. First of all, we start with a brief recap about lignin, because in our analysis it is fundamental and because it can become a very important material for a lot of green industries. Lignin is a complex thermoplastic polymer that we can find in almost all dryland plants, so we can also exploit it in order to create some products that are completely biodegradable. Lignin contains aromatic groups which are responsible for its properties like the stiffness, the sensitivity to sunlight, and the water repellence. The main function of lignin is to bind together cellulose and hemicellulose in order to give strength and resistance to the tree. In this presentation, we are going to analyze how wood can be used as an alternative to oil, and also or as a method for saving the consumption of oil. In addition, we are going also to see some companies that are performing studies on how to produce from wood biofuel, bioplastic, and thermal isolators. Starting from biofuels, they are obtained indirectly from biomass, such as corn, wheat, sugarcane, palm oil. And unlike fossil fuels, they are renewable sources, so we can regenerate them in a short time. This is not the only advantage of biofuel. We have also the advantages like sustainability, the greater security of supply, and the reduction of greenhouse effect. We haven't only advantages, but we have also a few drawbacks. For example, that they can remove land for the food production, and also that sometimes the energy required for the production of biofuel is bigger than the energy that they give us. We have two main categories of biofuels. We have first generation and second generation. First generation have a reduction of CO2 emissions respect to fossil sources that goes from 20 to 60%. Instead, the second generation have a reduction of CO2 emissions that goes from 70 to 90%. The main drawback of first generation biofuel is that they come from wood sources. Instead, the second generation ones comes from waste of production. So, for example, from forestry or from wood processing. Now we are going to analyze, as I said before, one of the most important companies, which is Statkraft. Statkraft is one of the biggest renewable energy producer, and it is a Norwegian company. Nowadays, they produce biomass starting from wood chips. And they produce this biomass with a low carbon footprint for heating and electricity production, and they also started producing the second generation biofuel. They also have an internal philosophy that in Norway not a single tree will be cut only to produce biofuel, and so they, for this reason, they only use branches or parts of the trees that they will dry it naturally, so the wood doesn't need any further process. Statkraft created with the Swedish company Sodra a joint venture called Silva Green Fuelt, which is a pilot plant for studies about the production of second generation biofuel. They introduced a new technology called hydrothermal liquefaction, which is a process in which we create second generation biofuel, and we start with wood chips. Then we add water to these wood chips, and we reach a mixture which seems like a porridge. Then we expose this mixture to high temperatures and high pressures in order to obtain oil. Then from this oil we add some hydrogen and we obtain diesel in a process which is similar to oil refining. The product that they want to produce, it's not addressed to passenger cars, but they focus their attention on planes, shipping and trucking, because these categories needs high energy fuels in the further future. Also, Boeing has said that their planes will use only biofuel from 2030, and their main goal is to cut of 50% the use of carbon, so reduce the carbon emissions in the mid-century. Now I leave the word to my colleague.
Okay, so thank you, Alessandro. Hello, everybody. I'm Francesco Albano, and I'm going to speak about the last two subtopics of our analysis. So, about Biomi Bioplastic, it is an English company which creates intelligent and natural plastics. It is important to say that in the production of bioplastics, aromatic rings are added in order to convey functionalities such as strength or flexibility, or also temperature resistance. These aromatic rings usually derive from oil, from petroleum, but as we know, lignin is the only renewable raw material that is available in large quantities, which contains these aromatic rings. So we could exploit lignin in order to replace petroleum-based plastic. But we have also to be careful about a particular characteristic of lignin-based plastics, because it's not as homogeneous as the oil-based plastic. In fact, in order to exploit lignin at its better, we need to divide lignin chains into its single components, and this is an operation that could be difficult to be carried out, especially in economic terms, because lignin has a very high resistance to breakage. So in order to prove the advantages of this type of biopolymers, Biomi Bioplastic has made a joint venture, we can say, with the University of Warwick, that makes academic researches about lignin degrading bacteria. We all know that there are animals like termites, for example, that eat wood, and the bacteria contained in their gut are able to break down the lignin. So these bacteria and other enzymes that were discovered by this university can decompose lignin into its single elements, and so they can be exploited in order to create some material like bioplastic. So starting from this assumption, Biomi Bioplastic has developed a new material in 2020 that takes less than 3 months to decompose, and it is designed in order to provide the structure for coffee pods, for coffee capsules. And also it prevents any deformation when it is exposed to hot water brewing condition that is, of course, typical of coffee making. So, speaking about the commercial targets associated with this type, with the introduction of this type of biopolymers, first of all, we aim at replace the oil-derived chemicals with the lignin-derived chemicals in order to convey functionality to this bioplastic, in order to convey strength and flexibility and temperature resistance, as I was saying before. The second commercial target is to further reduce any costs and at the same time to improve continuously sustainability. Speaking about the advantages of associated with the use of such bioplastics, we recognize first of all a reduction of non-renewable resources, because of course we replace part of artificial plastic with bioplastic. Then in a point of view of like life cycle assessment, after its useful life, bioplastic can be biodegraded, or also it can be recycled. So it's a great advantages, of course. And also we will satisfy all the portion of the market composed by those customers that request for green products, sustainable materials, sustainable products. That is a portion of market that is growing, so it's a growing trend of demand that we are going to cover. And also there is the possibility of creating bioplastics with specific properties, such as the natural decomposition after a certain period of life, with the consequent enrichment of the soil. And last but not less important, of course, there is a reduced use of energy in manufacturing this bioplastic. Okay, about the last part of our analysis, we speak about nanowood, which is basically a thermal insulating material. So we all know the importance of thermal insulation in every kind of building. Nowadays, the commercial thermal insulator are made of many materials, many different materials, like glass or wool or polystyrene foam, or maybe the most known is styrofoam, and is of course the most used. However, most of these materials have associated drawbacks because they are not environmentally friendly, they are expensive, and they usually end up in the landfills. For this reason, University of Maryland engineers have developed a new insulating material starting from wood, which is cheap and at the same time is biodegradable, and it's called nanowood. It is produced by taking certain cut of wood and by chemically removing most of the hemicellulose and the lignin from it. So we will remain just with cellulose. This because hemicellulose and the lignin make wood a good thermal conductor. So by removing them, we will obtain an excellent insulator, almost entirely made of cellulose that is a polymer which makes up the cell wall of the plant, and has been used as a thermal insulator for a long time. Speaking about the manufacturing process, it is very similar to the process of making paper. So first of all, we cut the wood, paying particular attention to its grain. Then this piece of wood will go into contact with special substances that are sodium hydroxide and then sodium sulfite and later on hydrogen peroxide in order to remove all the lignin and most of the hemicellulose from it. Then this semi-finished product will be then frozen in order to maintain the natural structure of wood. So after this process, the material changes its color to pure white. Change slide, please. Okay. It changes its color to pure white, which is a color which, of course, does not attract so much the solar radiation, as we know. So it does not attract heat as well. Also, the chemical treatment of wood leaves the cellulose fibers aligned along one direction, as you can see in the figure. So this makes nanowood an anisotropic material, of course, and this is an important characteristic because heat transmission will depend then on the direction of the fibers. Other important characteristics are that nanowood is capable of retaining at least 10 Celsius degrees of heat more with respect to styrofoam, and also it's way stronger than styrofoam because it's estimated to be 30 times stronger than this element. We took styrofoam as a reference because it's we can say the most used material, insulating material nowadays maybe. And also, as I was saying before, thanks also to its white color, nanowood, when exposed to the sun, it reflects approximately the 95% of radiation energy, absorbing just the 2% of it. And of course, it's a completely natural material, so it's almost entirely made of cellulose. So it is obvious that it's fully biodegradable, and this material will decompose in a short time after its useful life. Also, it can be produced in a wide range of shapes and sizes, including, for example, blocks, sheets, or rolls. And when its thickness is lower than 1 or 2 millimeters, it can be easily rolled. So it can be used for being wrapped around elements that have a particular shape, such as tubes, pipelines, or maybe joints, in order to thermal insulating these materials and these elements. Also, we have to speak about the cost, because often when we speak about sustainable products, we speak first about their advantages, but then there is an associated high cost. This is not the case because the authors estimated that its cost could be less than $8 per square meter. So all these characteristics make nanowood, we can say, a superior thermal insulating material that is way better than artificial material made of plastics like styrofoam. And this is another proof that wood is not only a material that belongs to the past or to the present, but is also an innovative material with which we can build our future. And we wanted just to underline once more this point in our analysis. We have finished our presentation, and so thank you all for your attention, and we are open to any question.
Okay, thank you also to you for this interesting presentation. In particular, I like the last sentence of Francesco when you said that with wood we can build our future. That's a nice sentence for me, as you can understand. Okay, are there questions from the students? At the moment, no hands up. From myself, you presented 3 different materials. One was the last, the nano cellulose as insulator, then the plastic derived from lignin, and the first one was the biofuel. It seems, if I've understood well, the biofuel is already on the market.
Yes.
And what about the other 2? Are they only part of the research, or there are already some products on the market?
About bioplastics, we can say that it was born in 2020, because in 2019 Biomi Bioplastic, the company we introduced, has received an order that was worth about $500,000 from an American company which operates in the sector of packaging, and so they Biomi Bioplastic has supplied to them these kind of bioplastics for the making coffee pods and coffee capsules. And also NanoWood is growing in its marketing.
Okay, and then what about the biofuel? Is the production is increasing? Do you have some data about the possible development of such interesting?
Yeah, that the aim of the producers of biofuels wants that in 50, 60 years. All the shipping, trucking, and planes will be used only biofuel. They call it like SAF, which means sustainable. Like in the airplane, they called it SAF, sustainable airplane fuel. And like Boeing in 2030, they want to have 100%. Airplanes using biofuel.
So it's a very, very interesting target and very ambitious. So if there are no questions, we can close also this second presentation. Thank you to Alessandro and Francesco. And now is the time for presentation number 11 from Jana and Maria Paula. The title is cross-laminated timber, so it's something related with building, I suppose. Yeah, okay, so now it's your time. Please go on and share your presentation with us.
Can you see the screen, the presentation?
Yes.
Okay. Our topic is CLT, as you have said. It means cross-laminated timber, and we will see it as a building material. I'm Jana Guerra, and I work with Maria Paula in Besi, which is a civil engineer, while I have the background of management engineering. Just a little overview of our contents. We will see why wood is considered a very good building material, Then what is CLT? We will see some examples related to the market segments. And then we will see more in detail the manufacturing process, the properties, benefits, disadvantages, and where you can use CLT inside a building. And then we will see some conclusions. So, why wood as building material? Well, of course, as we have seen in all the course and we have studied, it is a natural carbon sink because when the tree grows, it is able to trap a lot of CO2, and for this reason is a let's say an eco-friendly material, because as we know, the main topics in these days, also in these years, is sustainability, climate change, and so on. So wood has gained again its popularity in terms of as a building material, because usually we build with concrete, for example, which is one of the most used materials. And if we consider that to produce 1 cubic meter of concrete, we release into the atmosphere almost 1 ton of CO2. So if we substitute this 1 cubic meter of concrete with the same amount of wood, we will save 1 ton of CO2. But wood, as we have seen, being a natural material, is an isotropic material, so its properties are not homogeneous. And to face this variability, let's say, and of course to improve all the performances, there were developed these engineered wood products, which are also called the mass timber products. This term grouped together different building materials, such as, for example, glue laminated timber or nail laminated timber. But one of the latest innovation in this field, let's say, is the cross-laminated timber, CLT, which is also called X-Lam or Cross-Lam. It was presented by Gerard Schickofer in the 1994 during his PhD thesis discussion, and these construction systems were used first by German industries and also by Austrian industries, and so we can also say that it's a quite a new material. It has more than 20 years, but yeah. Basically, it is this construction system is based on the use of large multi-layer panels made from lumber boards, which are glued together. And as we can see in the first picture, the layers are placed one on the other with different alternating orientation of 90 degrees. Usually are used, the layers are not the number, and usually are used 3, 5, or 7 layers, not more, but it is possible to build also more layers. The trees mostly used are pine, fir, larch, but the most used is spruce. Due to the cross-laminated nature of the panels, this CLT is able to let's say, take up forces in all directions, and so there are a lot of applications such as walls, floors, ceilings, roofs. As we can see in this diagram, the residential segment dominates the market, and then we have also educational institutes, for example, or government and public buildings, and commercial spaces, which in these last years also the market is growing, especially in Europe, North America, and Asia, and others, for example, in industrial buildings. Now we will see some pictures, some examples. The first one, it's called Mjøsternet, and it was completed in 2018 in Norway, and it is currently the world's tallest timber building with almost 86 meters. Inside we have not only apartments but also a restaurant, offices, and some hotel rooms. In the second picture, we have the gym at William Perkin High School in London, which was completed in 2014. But in this picture, we see only the gym, but actually is a 4-story building, and it is the largest CLT building in the UK because it contains 3,800 cubic meters of timber. So think about how many CO2 is stored inside this building. Then we have on the left, we'll know the McDonald's, and it is placed in Chicago. In this case, CLT was used both for aesthetical purposes and also for structural ones, as we can see on the roof. On the right, we have the grocery Lidl, and this building was constructed in 2020, but it was certified as the first ever zero CO2 building in the world. And because in its entire life cycle, the net zero emissions, the net emissions will be equal to 0. And then the last example is the pavilion, Slovenian pavilion at the Expo 2015 in Milan. It has both wood elements and CLT panels, but since I saw it, so it's something I saw, and it was interesting. Yeah. Now we'll see the manufacturing process. We can split this process in 9 phases. The first one is the primary lumber selection. So we have 3 steps. First of all, we check the moisture content, which should be less than 19%, but it depends on the adhesive we are going to apply on the panels. Then there is the visual grading. We can divide the panels into types. Appearance grade in this panel are used for aesthetic purposes, and then the construction grade, which in this case the panels are used for the construction. And then the first step is an optional step, the stress check. We can perform additional structural tests on the lumbers. The second one is lumber grouping. So lumber are divided, for example, based on quality or size or knots or other structural properties and so on. Then we have the lumber planning. In this case, the a thin layer on the surface is removed in order to improve the quality of the surface for the later adhesive application. So from the top and bottom, usually is removed 2.5 millimeters, while from the sides 3.8. Then we have the lumber cutting. In this case, the lumber is cut according to the request of clients or according to some specific applications. And then we have the adhesive application. In this process, the lumber boards pass through this tunnel And we have some nozzles which spray the adhesive on the panel with at a constant rate. So in this way, the adhesive is applied in an homogeneous way. The most used adhesives are the phenolic ones and the polyurethane adhesives. Then we have the panel layup. So as I said before, the panels are placed one on the other with an inclination of 90 degrees. And the final thickness of the panel, it's between 51 and 500 millimeters based on also the number of layers. Then we have the assembly pressing, which is the, let's say, the final adhesion step. We can have the vacuum pressing. In this case, the advantage of this pressing is that we can press together more than one CLT panel at a time, while the hydraulic pressing allows to control, to set different pressures, and we can also have higher pressures. Then the quality control and cutting process, in this case the surface is controlled, let's say, and we can use in this phase a sanding machine to improve the quality. And with a CNC machine, we can create openings, very accurate openings for doors, windows, according to the orders or the client's requests. And at the end, we have the packaging and shipping, and of course, the final product should be must satisfy some standards. For example, we have the first one, which is American, the second is European, and the third one is the latest, let's say, and is the International Standard Organization. And from me, it's all. And now I pass the word to Maria Paola.
Thank you, Jana. So now we speaking about why the CLT, in particular, as you can see in this graph, why the growth in the use of CLT in building sector is exponential. The graphs arrives until 2015, but you can see the data before that the market size in 2020 grown up, and the value projection in 2027 growing up too. And we analyze that this is for three particular benefits of the material that we put in macro area of construction efficiency, performance, and sustainability. Regarding the construction efficiency, Jana, please, the slide. Regarding the construction efficiency, the CLT is able in almost every shape and size, which are usually limited by transportation requirements. The manufacturing company makes it on the base of different purpose and application, and the size and the characteristic of the material allows us to cut it with precision using CNC machines, and for example to the opening for windows and doors. This improves the efficiency in the use of the wood resource and minimizing the manufacturing waste and time, and guaranteeing the precision of the final product. Another important benefits is that the prefabricated nature of CLT allows for right pressures and construction process characterized by faster completions. In particular, that may be as short as 3 or 4 days per story, in comparison to more 28 days if you use concrete. And another benefits are the increasing insularidity and the less demand for skilled works on site. Regarding the performance, one of the most impressive advantages of CLT elements is their strength to weight ratio compared to the other materials. In fact, the reason for this can be found in the cross-laminated configuration of CLT, in which the adjacent layers of CLT elements support each other and act as a reinforcement, which leads to better mechanical properties, and thus CLT can be used as load-bearing elements and shape panels. That is a thing that distinguished the CLT from the other wood-based panel used in the construction sector. Another benefit is the height design flexibility, and this for the structural characteristic of CLT that allows for shapes and openings of most diverse size and form without compromising the structural integrity of the structure. And this allows the designer to have fewer elements to create the same stable construction that could be achieved with more traditional materials, adding to the simplicity of the system. Another good performance is the excellent fire resistance. This is one of the biggest fears of people about the wooden construction, the wooden structure, because usually people link wood with the fact that it is a combustible material, but the results of full-scale fire test show that CLT structure have the potential to provide excellent fire resistance, often compared with non-combustible materials. Regarding the seismic force, you can see in the video a test that was founded in Japan, and in this case, the buildings is buildings with 6th floor, and the test is with a magnitude of 7.2, and the result is that in terms of seismic performance of wood building perform well because they are lighter and more ductile than structure built with traditional material. The main advantage of CLT regarding to thermal performance is that it offers the possibility of creating a thick construction due to the large panels and the possibility of having fewer elements and thus fewer joints, where air could infiltrate the building. And so the CLT panels act as a thermal mass that store it during the day and realizes it at night. Regarding Jana, please, the slide, the sustainability. The CLT is an environmental friendly building materials. Its use does not cause any harm, and this material is used to reduce energy consumptions. In fact, the CLT is a bioresource and thus renewable material. In particular, is a carbon saving. In fact, the proponents of CLT claim that producing timber buildings components consume only the 50% of the energy required to produce concrete and a mere of 1% of the needed to produce steel. So the CLT buildings are not only a buildings, but are a carbon sink. Another benefit is the global warming potential that had a reduction of about 30%, 22%, than a building of similar design using concrete. This data came from an Australian study with a case study of Melbourne's Forte buildings. That is the buildings that you can see in the photo. And the last benefits is that the fact that the West are more or less in all stage from production to the buildings to the building process. Now we analyze the disadvantages of the material. In particular, the disadvantages are caused by the fact that the material is not available in many cities and countries, and so is a new material, and for this its limited track record, and can be difficult for many designers to use. And this is the case of the risk of illegal lodgings, and this is a bad fact for the environmental impact. And another disadvantage is the price that because they would have more expensive price in comparison with steel and concrete. So where can you use CLT in a build? For the reason that I tell us until now, we can use the CLT in roof, in berms, in flooring and decking, and in particular for what concerns the wheels are formed by multiple layers used with CLT for such as weather protection on the outmost walls and insulation, the CLT panels and internally lining for the inside. So this is very important for the external walls in particular. The material is now used to construct impressive and sustainable homes, offices, schools and towers. So to conclude, the use of CLT has marked a significant transformation in the way buildings projects are conceived, shifting the design from frame to plate-based construction, proving designers with a new and more environmentally friendly and aesthetically appealing building solution alternative to concrete and steel. Wood is the only building material that helps tackle climate change, and it is important to remove carbon from the atmosphere as well as reduce new carbon emission, and the CLT achieves both of these. And the use of CLT has marked a significant transformation in the way building projects are conceived due to its environmental, structural, and economic performance. So the world needs a new approach to materials, in particular in the building sector, and the CLT is a good answer to this new approach. Thank you for your attention, and tell us if you have some questions.
So thank you for this presentation that again it is dealing with the wood, the necessity to use more wood. So finally we are very close to the end of my course, and I think that I hope that I was able to convince you about the use of wood, but it seems a success for me. Are there questions from the students today? No many questions.
Yes, Professor, I have a question.
Okay, thank you very much.
Okay, I have a question about the life of the product, because in my experience, when you create a home in wood, for example, you think about the life of the owner. But when you are going to create a building utilizing wood, yeah, when you think about a building, you think about a structure with, say, Yeah, which has a long duration, so many years. And my question is, wood is able to maintain the structural characteristic for a long year?
There are studies. I read some studies that said that CLT is able to live more than 100 years, and there are some techniques, let's say, also to protect it from natural, like, I don't know, fungi and all environmental dangers we have seen also during the course. And then for the since you select different lumbers with some precise characteristic, because you don't take one piece of wood and you put it in a building, so you have to select for different buildings, different materials, different species, and so your project will be a long life project. So yeah, I hope that I answered you.
Yeah, so the answer is yes.
Okay, another thing is that you can think that the concrete has a useful life of about 30 years. So is compared to wood, is a good wood for the construction building.
Thank you.
Okay, thank you also to Francesco for his question. Just one comment from me. The experiment you shown about the seismic behavior. It's an Italian project that was tested in Japan, but the project was Italian.
Yeah, actually, on the building there was the flags of Italy and Japan.
Okay. No, just a little comment from you about the fire resistance, because you said that incredibly this material is fire resistant. Can you say something more, because I think it could be a surprise for many people to hear that wood can resist to fire.
Yes, there is some study about this, and the fact that the wood is resistant to the fire is for the CLT CLT structure that are have the property to have a good good resistant for their layer, and that protects not carried wood and
Yes. Not normally the secret is the section, because if you have a big section,
yes, for the big section.
Yes, it's the same when you have a fireplace. If you put little pieces, they burn immediately. If you put inside a big piece of wood, it takes hours to burn because of the low thermal conductivity of this material. So it burns, but very, very slowly. So it normally allowed to the people to escape from the building before of the collapsing of the building itself. So, okay, so thank you. It's again a very interesting presentation. There will be many other comments from myself, but it's 5:30, and we must go on with the other presentation. So thank you again, Jana and Maria Paola. And now it's the time for group number 12, yes, from Ujival, sorry for presentation, and Armagan, and the title is Wood Recycling. So please start the presentation.
Okay, good evening, everyone. My name is Armagan. I am with my group member Ujjwal Bhandari is going to present you our topic, which is on wood recycling. Next, please. The main contents of our presentation are introduction, a brief introduction, then I will tell some wood recycling processes, then the advantages, some challenges, and at the end references. Introduction. Wood that is taken from the furniture industry for recycling is called as deadwood, and the process is used to turn the waste wood into usable products. The process consists of several steps. First, the waste wood is dispersed on the conveyor belt and it is sorted manually. Some parts such as glass, ferrous, non-ferrous metals and plastics are removed. These parts are sent for the further recycling or utilization separately. The dead wood is then crushed with the crushers and cut down into pieces using several equipments. And the acquired material is delivered to the manufacturer for the various purposes of recycling to form another products. Next, please. On the figure 1, you can see the waste wood generated and the wood recovered. In 2010, the generated waste wood is about 60 million tons, and whereas in 2016 it goes down slightly, whereas the recovery is almost remains same at 15 million tons. In the figure 2, you can see several ways of wood waste treatments, which include disposal, incineration, energy recovery, recycling, and some others. Out of all these, the energy recovery and the recycling is the most common use wood waste treatment processes. And according to Eurostats in 2016, about 55 million tons of wood waste is generated in European Union, and with over 48 millions was treated, which is about 88%. Next, please. Some wood recycling processes. The first one is cement bonded particle board. It is also known as wood cement board, WBC. It is first commercially manufactured in 1970s. It is the mixture of, you can say, the wood particles and the cement together with some additives. It is a good sound insulator and it is dimensionally stable. The color of this board is gray because of the presence of cement. Next. The manufacturing process for cement bonded particle consists of several steps in which cement, wood and water is added in different quantities, ratios. Cement is added about 50 to 60%, whereas wood is added about 25 to 25%, and water is added about 25 to 30% in the ratio of 2.2, ratio 1 up to 1.1. And the density is around 1100 to 1200 kilogram per meter cube. And there is another form which is called oriented wood cement board, in which the density is decreased at 850 kilogram per meter cube. The uses of cement bonded particle board are exterior and partition walls, thermal insulation, flooring, prefabricated houses, roofing, and the fire resistance construction. Next, please. The next one is wood plastic composite. We use polyethylene, polypropylene, and polyvinyl chloride are used instead of usual resin adhesives, and mix with about 35 to 70% of wood flour. Rice husk, straws, and other waste plant fiber can also be used to form WPC. The processes which is famous for the composition of wood plastic composite material are extrusion, molding, injection molding, plastic processing, and the use is mainly for the building material, furniture, logistic, and the packaging industry. Next, please. Binderless wood particle boards. A panel of wood particle that can be cellulosic fibers, and we use only water, heat, and pressure to form the binderless wood particle boards. No external adhesives are used, and wood lignin and hemicelluloses act as the adhesives. Next, please. Its manufacturing process consists of different steps in which the particle preparation, then framing, and hot pressing temperature that can be from 150 to 250 centigrade with the moisture content of 20%. The compression rate depends upon the particle type, and the pressing system usually from 0.1 to 3 megapascal. The density is around 450 to 1350 kilogram per meter cube. Then the frame is removed and the mat is formed. The final pressing is occurred at 160 to 170 degrees centigrade to get the final product. The uses of binderless wood particle boards are in light construction, sound insulation, and partition wall making. Next, please. The next is the pelletizing procedure. A pellet is also called a skid, and it is a flat transport structure which supports goods in a stable manner to be lifted by the forklift or the pallet jack. It is the structural foundation of a unit load, which allows the handling and storage in an efficient way. Good or shipping containers are often placed on a pallet, and the composite pallets, the type composite pallet are manufactured from the combination of wood and other material, which include the molded blocks using the waste wood. The composite pallet is totally recyclable, and using sawmills, the waste wood are trimmed to proper length and ripped into the boards, and then we get the pallets. Further, Ujjwal will continue.
Thank you, Armagan. And my last topic is the biomass, which is another type of the wood recycling process. So basically, we have been hearing this word biomass from our school days, and we know that the biomass is the wood waste, the waste that is developed from various sites. It can be either from the wood waste, or it could be garbage, or from the dead crops. So basically the wood biomass that comes from the forest and the woodlands from the various furniture industries. This biomass contains the stored energy that is developed from the sun. During the photosynthesis process, the chemical energy being developed is used in the form of the biomass. The developed biomass energies can be used in various purposes. For example, it can be directly heated or can be stored in liquid or in a gaseous form. The several applications of using the biomass is that it is used as a means for transportation, and also can be used for heating purposes of the buildings and generate electricity through the steam turbine engines. Here are some of the converting procedures of the biomass into the energies, and there are this includes the direct combustion, where this is the widely used processes where the biomass is heated at a very high temperature and the energy has been extracted. These energies can be used for heating of the buildings, like heating of the waters, and also can generate steams for the steam turbines. Also, this sort of heats are used mostly in the industrial purposes. The second one is the thermochemical conversion, where it consists of 3 different processes. Like they have, it's the pyrolysis, here hydrotreating and gasification. The pyrolysis process occurs in absence of oxygen, and it's heated at around 800 to 900 degrees Celsius. The process is similar to the direct combustions, and the applications similarize both the direct combustions and this thermochemical conversions. In the hydrotreating processes, it's similar to the pyrolysis, but it happens at a very high temperatures and pressure with the presence of a catalyst. And the main thing is that it happens with hydrogen, so that the process occurs at a faster rate. And also the gasification, this happens at around 800 to 900 degrees Celsius with the control amount of oxygen being passed to the vessels. This produces a gas called the synthesis gas, which is the mixture of carbon monoxide and hydrogen gas. The hydrogen gas is separated from the carbon monoxide, and the carbon monoxide is further treated, whereas the hydrogen gas is stored and can be used for the further processes. The third one is the chemical conversion. In the chemical conversion, the organic waste or the bio waste are converted into fatty acid methyl ester, which is also known as FAME, FAME. And these fatty acid methyl esters are added added in a certain proportions with diesel to prepare biodiesel. The biodiesel is one of the sources can be used for the applications in the vehicles. And this is nowadays trending further hybrid vehicles to develop and run through these biodiesels. Also, the fourth process is a biological conversion, where the organic waste or the biomass is been converted into ethanol in absence of anaerobic respirations and anaerobic degradations, where the renewable energy natural gases are prepared. These natural gases can be used in the vehicles for the transportation purposes, and also can be used for the heating purposes, or can be used for cooking dishes. Now we come to the benefits of the wood recycling process. First is the environmental impact. Surely we know that if we recycle the woods and start using the recycled wood, then we will be less using the new materials, and hence the less material will go into the landfills. Like it will be more when recycled, and it will be highly used time and again. Also, the reduction of energy cost, like it costs a lot of money in order to prepare a new material. So instead of it, we have already prepared or the recycled one can be used in order to reduce those costs. Also, there are several new opportunities being developed because of using this recycled woods. For example, the various research and developments are carried out in these fields, and also people demand for sometimes different quantities or different qualities of the recycled materials. Also, it changed the mentality of people. Like it was taken as a survey that most of the people, they do not believe in recycling. So while the benefits is that with the recycling, it helps people to change their mentality in recycling more and making them more environment friendly and keeping the environmental much more clean. Also, it has several applications, as I mentioned already, that it can be widely useful for the industrial purposes, heating of the apartments, buildings, and generation of steams, and can be used in functions for functions in furniture as well as into the transportations industries. The process for the wood recycling is a kind of a complex job, so it has certain challenges. The major challenges that one faces, the company facing, are the material impurities. Like during the wood recycling processes, there might be certain other impurities might be present, like for example the metallic pieces, plastics, and all. So this results in losing the quality of the material, and losing the quality of the goods results in the low demand of the low demand of the goods. So hence the material impurities in the wood recycling process has become one of the prominent factors that are the challenges that has been to the industries where they do this wood recycling processes. Also, there are lack of policy measures. For example, the policy makers or the ones that are creating these policies are that not much sufficient. An example could be like if there is a deduction in a tax, like for example, if the tax is being deducted into any recycled woods, then people will more emphasize and the company will more emphasize on making those wood recyclings. Instead that the tax reductions and various other policies if are created, for example, also the storage facilities are are created, then this will help for sure the companies to develop new and different types of the recycled products. The another last challenges is that there is lack of storage and equipments. The main first risk that comes while the wood recycling is that if the fire breakouts into these storage places, then that's an health hazardous even to these capital as well as to the human lives. Also, the handling of this wood recycling requires a lot of equipments, like for example the dozers and the cranes and belts and even various machinery. So these effects in the wood recycling processes. So here are some of the references that we collected, and pay attention. If you have any questions, just let us know.
Okay, thank you for your presentation. Are there questions from the students? No, at the moment. In any case, I think that your presentation was an interesting summary of wood recycling, and also you mentioned also some of the problems we have with recycling in general. The change of mentality is as you said, and also from my experience, I think one of the most difficult efforts for the human beings, because changing habits, it's very, very difficult. You didn't say something that I would like to add, that maybe also a change in the design of the product, because, for example, we must easily separate the different materials. Can you comment something about this needs of also design the furniture and other products in a different way if the goal is recycling?
Like in the field of recycling processes, various products or various varieties of products. For example, using the various small the chunks can be used to develop the cork in the wine bottles. Similarly, like this sort of things can be used for different purposes and various applications. Might be there's some changes in these changes in the different types of wood variations being used, and using of various wood variations to create different type of designs to look at more aesthetically beautiful, and to have it naturally look as a new material can be done in this matter in this field.
Okay, thank you. So I don't see hands up from the students, so we can close here also this interesting presentation. As I said last time, if you would like to send me the presentation, I appreciate. It's not mandatory because it's your material. But as I said, I like to see again what you presented, and so if you like to do, I will say simply thank you. Okay, thank you. Where do you come from? The last question.
I come from Nepal, and Armagan comes from Pakistan.
Okay. Thank you again. And now it's time for the last presentation from Francesco and Friedrich. the presentation is about cellulose-based superabsorbent polymers. So this is a very, very specific presentation. Okay, so you have already shared the presentation. We can see on our screen, and so please
yes.
Go on.
Okay, yeah, thank you very much. So I have to switch on the camera as well. So yeah, thank you very much. My name is Frederick Meyer, and today I'm going to present together with my colleague Francesco Palcice the topic cellulose-based superabsorbent polymers. And yeah, so first of all, we see here our index. We first introduce to this material. Afterwards, we say some words about some possible application fields of superabsorbers. Then we want to explain the principle. And afterwards, I give the word to Francesco, who's introducing the material cellulose-based superabsorber. And afterwards, we have a conclusion. So yeah, what are superabsorbent polymers? We see here on the right-hand side a picture. This is the powder, this is the material, this is the superabsorbent polymer. And this material has a special property. It is hydrophilic. So this means that it can absorb huge amount of water. And we can say that this material is able to absorb up to 1,000 times of its own weight. And it is also referred as hydrogel. And we also prepared a small experiment so that you get an impression, that you get an impression of this. Just let me check. Okay. Just wanted to share one thing with you. So okay, I can do this like this. I don't know why it works. So can you see the picture?
Yes.
Okay. So what is inside here is just simply water. So we have about 50 milliliters of water, and what I have here in this tube is the superabsorber. This is the material, and we want to show you now the experiment. So we want to put just some grams of this absorber inside the water, and then we will see what happened with this material later on. So okay. Now we come back to the presentation. So yeah, where are superabsorbers used? We have several application fields, beginning from the biomedical to the agriculture, the construction sector, and the most important sector is the hygienic sector, where it is used for disposable diapers. In the construction sector, it is used for concrete, for example, as a mixture to avoid cracks, or also for sea cables. If they are damaged, then the superabsorber absorbs the water to protect the cable. Yeah, now I said before, the superabsorber is a polymer, and to be more precise, it's a copolymer. And in this case, we have two different monomers. And the two monomers are acrylic acid and sodium acrylate. And as you can see it here on the picture, it is yeah, produced in really huge chemical companies. And the base of this material is from petrochemical background, so it is not renewable. And we can also say that about 30% of the produced acrylic acid is only consumed for the production of superabsorbent polymers. And in the future, the demand is increasing. So now we want to explain the synthesizing process of superabsorbers. It's a radical copolymerization. So in the beginning, we have the two monomers that are represented by the green and blue points. And after, in the second step, we have regenerating our copolymers by some radicals that build the polymeric chains. And in the third step, we add a crosslinker that crosslinks these polymeric chains to a strong polymeric network. And these yellow dots here represent the chemical bonds. So it's a really strong polymeric network. Now we see a really short principle how this material works. So on the left-hand side, we have the compromised polymeric network. We can also see again here these chemical bonds. So this is the compromised network. And if water is entering to this network, this polymeric network is swelling. So the water is diffusing inside the network and leads to a swelling. And swelling, it's possible to enter, so the water can, lots of water can enter through the swelling because there's enough space for the water. And inside this network, the water is bonding to the polymeric network, especially to functional groups, and is bonding with hydrogenic bonds and also ionic bonds. Okay, that's so far. Then we see here an application of a superabsorber in agriculture. So on the left-hand side, we have a seed inside the soil. And on the right-hand side, we have the seed also in the soil, but with an additional hydrogel or superabsorber. And what happens now if it starts or begins to rain? The soil gets wet. And in the case of the superabsorber absorbs water. So we see it here on the third picture. The soil is wet. The seed gets water. And here we can see that the superabsorber absorbs high amount of water. And as an effect, we can see here the plant can grow without any additional water, while the plant in the common way without an hydrogel needs rain again to grow. But we also have to say that if we use common SAPs, we do nothing else than putting plastic inside the soil. So common SAPs, as I introduced, had a bad biodegradability, and they are not renewable. And now I would like to give the word to Francesco and say thank you for your attention.
So, as we have seen, the biggest drawbacks of common SAPs is the fact that they are a polluting product, since they are not biodegradable. So for this type of applications, such as in agriculture, they can represent a problem for the environment. But a solution came up in the last years, and is to use cellulose-based SAPs. So in the next slide. So what are the advantages of cellulose-based SAPs? Certainly, we have the fact that since they derive from cellulose, they are biocompatible, they are biodegradable, they are also a renewable source, since cellulose can be obtained by plants or also bacteria that can synthesize it. It's also a non-toxic product, and other than these eco-friendly aspects, we must consider also some economy. So cellulose is also a product with a large availability, and it has also low cost. So the idea to use this type of product is doable. We have also to consider that cellulose-based SAPs have very similar properties to common SAPs, since they have a high absorbency and high an high mass swelling ratio, and a high strength. That means that they do not dissolve into water when they are watered. So how they work? So you certainly remember that cellulose is composed by polymeric chains of glucose that present these hydrophilic groups composed by oxygen and hydrogen, and then water can enter these chains. And we remember that this is a problem for wood, but in this case is a main property that is favorable to our applications. So how these hydrogel are prepared? We start from cellulose that pass through a process of etherification. Then we obtain an aqueous solution of these cellulose derivatives that are called also cellulosics. Then these cellulosics pass through a process where cross-linking agents are added, and this prevents the dissolution into a liquid of the cellulose. We must consider also that to have a non-toxic product, also the cross-linking agents must be non-toxic. There are also other processes like the use of radiations, but they are not fully developed. By the way, non-toxic cross-linking agents are available also today, so we can have a completely eco-friendly product. Finally, this aqueous solution passes through a gelation mechanism where we have at the finish the dry hydrogel. So basically, cellulose SAPs can be a substitute to common acrylic SAPs in all of their fields. For example, in the biomedical field, they can substitute acrylic SAPs for soft contact lenses, drug release devices, wound healing dressings that are common with acrylic SAPs, but also in we can say new applications, for example, cultures, substrates for bacteria or viruses in laboratories, or as for example for people who have a kidneys problem, so their body cannot work well with the water. They can ingest these SAPs that then passing through the intestine, they absorb the excess of water, so contributing to the normal functioning of the organism. Also for obese people, they can ingest these SAPs, so they swell in their stomach, so they feel more full, like they are full of food, and they are not more hungry, and so they can eat less. And also for hygiene products are currently used, for example, in diapers, female napkins, or any other absorbent tissue that has some hygiene purpose. Also in the packaging of food, they are used to, for example, absorb the excess of blood of the meat in its packaging. Finally, as my colleague explained before, in agriculture, they are also used, and they overcome the problem of the biodegradability. So they can also bring with them pesticides and fertilizers, but when they are finished with their purpose, they just degrade into the soil, contributing to the nutrition of the plants without any further problem for the environment. So, in conclusion, In conclusion, cellulose-based hydrogels are yet used in many different fields, mainly in the fields where common SAPs can't be used. So, for example, when I talked about stomach bulking agents or water retainers, but there is still a lot of research to do in this field. So for the other fields, they are not so common. But anyway, the trend for the future is to try to substitute plastic-based products as possible. So with a further development of the processes of the properties of these hydrogels, we are going to see a large-scale application of them in the next years. So now we can see how they work. And so I give back the word to Frederick that can show to us how the experiment has gone.
Thank you very much, Francesco. So now let's see what happened. Okay, we see the material has absorbed the water, and a hydrogel was built, and we see the state is really solid of this material, and we can even turn the glass, and we see the material is leaving on the bottom, and it's a really solid material, and we can touch this material, and it is really plastified, and as you can see on my finger, it's not wet, so it really absorbs lots of water, and if I compress it, the water is leaving inside the network, inside the polymeric network. And from our yesterday experiment, we see here also similar material, and so if I compress it, and then you see my fingers, so they are really dry, and the water is leaving inside the network. So that's it from our part. So if you have any questions, or first of all, we say thank you for your attention, and if you have any questions, we are open.
Thank you for this interesting and nice presentation. The experiment was really nice. Is it reversible? So if you hit, for example, the solid, you can evaporate water and go back to the powder. I imagine.
Yes, yeah. It's reversible. So it continuously water is removed continuously, but really slow. And you can dry this material, and then you get the initial material. So you get the powder back, and so this is the same case if you put these super absorbers inside the soil, then it is a continuous process. So it absorbs water and it releases water, and this is from time to time it repeating this process. So and this is also the negative point. On the one hand side, it's a good property, but on the other hand side, it is a negative property because of the degradability of this material, because this material, this functionality is working on and on. So.
And can I ask you where the idea of this presentation come from? Did you have experiences in your universities with it, or simply for is a casual?
It comes from me, since I have some familiars that produces this type of products, and they have launched in 2017 a line of cellulose-based SiPs.
So it means that it's already on the market, and I
Yes,
think
yes.
widely used.
Especially for diapers, they are yet used a lot for baby diapers.
Okay.
Yeah,
okay.
and for example, this material we get also from diapers. So we cut the diaper and pull out the super absorber. So it's really common material and a really huge market, and also a market that is rising and increased in the future.
Yeah. Okay, I don't see hands up. So today only one question for 5 presentations, but in any case, I think that it was a success. Different subjects for me very interesting. I've learned also today something, and I'm always happy when I learn something. And thank you also to you, to Francesco and Friedrich. I see Francesco Destro. Do you have a question?
Yeah, Professor, I'm sorry for my timing, but I have a question. It's about the agriculture use. So you show on the picture the difference when you use it or you don't use. My question is, you have to put it on the ground every year. So every time you plant something, you have to put this material, or considering that it's not biodegradable, it stay here and you put it one on 5 year or 10 year, maybe, I don't know.
I would say you put it each year inside the soil, because you also have to prepare the soil, and so it's only a small amount of this super absorber. So as you saw it from our experiment, it's just a few grams of this material. So yeah, yes, it will keep inside the soil, but if you want to be sure that you have really good results, then it is better to repeat this process and constantly add these super absorbers into the soil.
Okay, thank you.
Okay,
so another question.
It's 10 minutes past 6. So if there are no other questions, I think we can close this lecture.
I have a little other question. If
okay, sorry.
Yes, please.
Is this material also a substitute of silica gel in, for example, in the boxes of the shoes or in the bags?
Okay.
No, this is not a super absorber. This is another material, but this is not the same material.
Okay, so it's not a possible application of.
No, it's not a possible application. And one special property of this material is also, if you have this powder is not reacting with the humidity on the climber. So this powder leaves or is keeping its properties as a powder, while the material that you mean inside shoes, for example, or electronic devices, this has the task to absorb the humidity from the air. So and this material isn't doing the same.
Okay, thank you very much for the answer.
You're welcome.
Yeah. Okay, thank you for also for this clear explanation. But now I think it's the time to really close this lecture. I think it was the most interesting lecture of this year. And thank you again to all the students, and see you on Friday for the very last lecture. our course. Okay. Bye-bye. Thank you.
Thank you.
Thank you.
Bye.
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 Thank you.
Thank you.
Bye-bye.
Goodbye.
Thank you, Professor. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.